this, for example, this is kind of a mother document, mother reference for all the references that I want to take up. Yeah. So this is an interesting contest announced by this particular coalition, the Woodside Human Performance Alliance, Restore Center, Mobilize Center. These are all different units of Stanford University and associated with Stanford University. So this is an interesting coming together of groups to really bring out something like a breakthrough technology, of which few important ones, or definitely important ones, which are of our interest are OpenSim, OpenSim Moco, OpenSense, and OpenCap. So I uh, would want to dive deep into this so that we get an overview of what these software tools are and what our interest specifically is in these different software tools. So it directly brought us to the projects page of this Mobilize Center, as you can see. Um, it is a research organization into development of technology, mostly open source technologies. And if we just quickly look into, interestingly, they have something called available data sets and data sharing communities. This is quite an appreciable thing, I would say, Dr. Denny. Now, again, as part of their whole program or set of programs, there are these different uh, types of knowledge sharing sessions that they create and forums that they organize, and so on and so forth. So, I would really encourage you to look into this page, please. As you can see, it is called mobilizestanford.edu, and within which here now I'll try to reduce the mm, size of the page. It's not happening. Yeah, but however, OpenSim, which says software platform with both API and GUI for musculoskeletal modeling and simulation. So this is the core of all our activity, or the core of this organization, this part of musculoskeletal modeling and simulation. And this is a very simplistic example of a musculoskeletal model through which we can do simulations. Now, coming here, OpenSense is a slight variation from OpenSim in that OpenSim usually takes the 3D marker system you might have seen in motion capture laboratories, camera-based ones. Whereas OpenSense considers the same musculoskeletal models, because end of the day, they are a bunch of mathematical equations, but now replaces the markers with IMUs, the sensors that you have seen at Dr. Ramesh's office the other day. And these particular bunch of partners, Mobilize, Restore, Stanford Biomechanics Lab, Human Performance Alliance, they all together bring variations of how OpenSim can be applied in real world. And OpenSim Moco is an example of that, wherein, sorry, wherein there is this musculoskeletal model, which is usually called an OpenSim model, is introduced into the environment On the top, we have goals, let's say minimizing effort, or let's say stabilization, or fall prevention, or some kind of aim of why we want to do this whole activity. And on the bottom, you see data, which could be the red ones are usually muscle activity sensors, the EMG sensors. Markers are for motion capture, and these arrows on the bottom are to measure ground reaction forces, which here it says as external forces. Now, a good combination of these things, the ground reaction forces, the muscle activity data, and the motion capture given by the markers. This is a great set of information which the model would be very much interested to take the data and give out outputs such as you can see here, the muscle behavior, the biomechanical efficiency of motion, movement coordination, which can be used across a range of movement issues that you may already know. So it is this platform is facilitating that, but here it is not clearly mentioned if it can take IMUs, which is a question. And it says software tool for solving musculoskeletal optimization problems. And I would definitely encourage you to dive deeper, which I can only, or you can ask your questions as well, not a problem, anytime. So OpenSim Moko says motion tracking based on experimental data example from wearable sensors. This is great. Motion prediction without using any experimental data, which means the model has become so sophisticated um, that it can create forward dynamics. Parameter optimization, example, stiffness of an assistive device, the location of a sensor. This is fantastic. This is fantastic. So now that we have come to this far, I would say, Dr. Denny, that we are actually creating an environment like OpenSim Moco in our startup, wherein we are borrowing musculoskeletal models from existing repositories, and we're also trying to optimize and Indianize these models. And on the bottom, we have access to EMG sensors, we have access to force plates, we have access to markers, the gold standard, and we have already our own sensors to be able to get as good as the markers. And eventually, with meaningful goals taken into the project considered, we want to give out the biomechanical information, which includes the muscle behavior, the biomechanics, movement coordination, and other derived parameters, temporal and spatial, kinetic and kinematic data. Whereas kinematic data is our utmost priority. Kinetic, it depends. Dr. Ramesh has to participate in the conversation. So it says the method using which the tool is built. That's what they say. And let's move to the previous page quickly and then talk about add biomechanics. So this is again a fantastic initiative from Stanford, wherein any person from anywhere in the world, any person anywhere in the world, if the person has a bunch of marker data, 3D marker data with him or her, They can just upload it to this particular platform and ask for results. Quick glimpse into it. This is a good representation. Here it says prepare the subject, record your trials, upload marker data. This is the infrared camera-based marker data, and automatically optimize a model for your subject and your data in minutes. So this is a fantastic tool. And here, actually, this is a good a flow of what we want to do as a company, wherein this whole marker data we want to replace with IMU data. Here you see C3D. Dot C3D is a clear indication that this is marker-based data and not IMU sensor, wearable sensor based data. So this, the depth to which uh, these tools can be utilized for our purposes, and the validity of it all, this could probably be a good case for a pilot study. The phase one, you may want to call. I'm going to go to the previous one. And after at biomechanics, we are talking about another tool set called metabolic expenditure estimates. Software for estimating energy expenditure during movement using two leg worn IMU sensors. So this is perfect for uh, our reference, I would say, Dr. Danny. So energy expenditure is an important concept, for sure in sports, and also definitely in rehabilitation as well. Because usually, if I'm not overstating, the whole aim of training gait, or other particular movements, the underlying uh, usual aim is to reduce the energy spent, to biomechanically or otherwise optimize the whole movement so that less energy, as less as possible, is spent and still having great functionality and mobility. So that way, this toolbox is something we may want to immediately use if if our clients speak about uh, energy expenditure or even mechanical loading. Like one of the questions, if you have seen here in Moco, it says loading. Loading is a great avenue that is applicable for us. Energy efficiency. Just now we are seeing energy expenditure. This is also applicable for us, and kinematics. We already spoke. I'm just highlighting for your reference. Through IMUs, what we can best get is inverse kinematics or kinematics only. It is not muscle activity, um, or any neural activity. It is only and only inverse kinematics, which is nothing but joint angles, I would say. So future work will combine this one, and this probably even sums up our company's effort. We want to leverage on the existing tools and be able to predict reliably predict reliably other parameters through a minimal set of sensors. This could really sum up our whole efforts, Dr. Denny.